Thank you for that. That's the beginning of the video. All right, so we're looking at how to calculate the gradient. It's telling us we want to calculate the gradient between point A and point B. Those are the only 2 points that matter from the entire map. All of the other points, ignore them. If you look on the front of your reference table, it shows the formula for the gradient equation. And it says it's equal to the change in field value divided by the distance between the points. In this case, the field value, we're going to be looking at pressure gradients. So the field value would be what is that pressure. The field value is just what is the number on the map. And we're looking for the difference in them. And difference means?
Subtraction.
Subtraction. So we're going to look for the difference in field value. So just take the bigger one minus the smaller one. So it's 22 minus 19. So the difference between the 2 points, B is 22, A is 19. That would be the difference in field value. Yes?
Can I say it?
Not yet. Because we're not done yet. Divided by, we want to divide that by the distance between the 2 points. However, you do not want to take out your ruler and find that it's like 2 centimeters away, because this is a map which represents some larger area. And at the bottom of the map, there's this nice scale which allows you to determine how far apart they actually are. So that's where your little scrap paper is going to come into play. And you're going to make a little mark where A is, and you're going to line it up, A to B, make a little mark where B is. And you want to find out how big of a distance that is. So you're going to bring it down here to your scale. And so it's got all these numbers on here. It tells us it's in meters, even though I just crossed that out. So if we hold up where A started at the 0, up to the very end, this would be 0. This portion here is 4. But we're going beyond what that little scale measures there. So we need to scoot it over. From here to here is 4, but we have a little bit more distance to go. So we're going to scoot it over to the 4. And now it's up here. This is 0 to, this is another 2. So the total distance is going to be 6 meters. Here to here is 4. Here to here is another 2. 4 plus 2 is 6. Yes?
How do you know you're like specifically to that next number? Like how do you know it's going to be at the 2?
Because I hold it up there where the 4 stopped. I made a little mark. I said, okay, up to here is 4. Now I need to find out how long this is, and I'm going to hold that point up here, and it's at the 0, and it ends at the 2. So I'm just measuring the line on the scale down beneath.
And that's all the space in between these two, which was the original marking.
So you have to make a line like that.
So you need to make a mark where A is and a mark where B is. If it's longer than your scale, you need to make a little bit of a mark where your scale ended, and then scoot it over and add another, how far does it go? You might need to do that a couple of times, depending on how big your map is. So it's 22 minus 19, the difference in the field value, divided by the distance. In this case, the distance is 6, which we got from our little scrap paper. So then you're going to, in your calculator, 22 minus 19 is 3 divided by 6. 3 divided by 6 is 0.5, but we do need units. So if I come back to the map, it tells me that the field value here was temperature. So the difference in field value, it was 22 degrees Celsius minus 19 degrees Celsius. That difference is 3 degrees Celsius. And my distance down on the scale, it said was in
millibars.
Meters.
Oh,
Distance. So distance would be meters, kilometers, it might be miles, but some unit of distance. So it's over 6 meters. So 3 divided by 6 is 0.5. The units are just whatever the units on the top were, divided by whatever units on the bottom were. So 0.5 degrees Celsius per meter. So that means for every meter that you walk, it's a 0.5 degrees Celsius change.